Please confirm you can hear me clearly.
Good evening, sir.
I hear you, sir. Good evening, sir.
All right, thank you. All right, tonight we shall continue with the topic option theory and valuation. This should be our third topic, our third lecture on this topic. Precisely tonight, we are looking at the application of option theory to investment appraisal. Precisely tonight, we are looking at the application of option theory to investment analysis. We understand investment appraisal. Usually, we appraise investments to determine the financial viability of the investment project. The primary reason why we conduct or why we carry out financial flexibility is to determine the viability of the investment project. And usually we use the net present value. We use the net present value to assess if the investment is financially viable or not. Tonight, we want to look at evaluation of investments using the concept of option theory and valuation. The option theory enables us to value financial flexibility. Financial flexibility that is available in investment projects. What are these financial flexibility? This financial flexibility shall be considered under 4 headings. Financial flexibility shall be considered under 4 headings. In other words, there are 4 areas of application. There are 4 areas. Option theory can be applied to investment appraisal with an intent to value financial flexibility. What are these areas? One is option to abandon a project. Option to abandon a capital project. Under the conventional net present value method. Under the conventional net present value method, it is assumed that a project will commence at year 0. And this project will run until the maturity of the project, until the final year of the project. That is the assumption with the computation of net present value. A project commences in year 0. The project will run for year 1, year 2, year 3, year 4, up to the final year of the project. That is the assumption for the calculation of the net present value. However, where project expectations are not met, where project expectations are not met, the company can decide to abandon the project pathway and dispose the project. However, where project expectations are not met, the company can decide to abandon the project pathway and sell such projects. For example, you have a project for 5 years. From year 0 to year 5, you are going to invest 500 million in year 0. That is the initial capital outlay. You now have year 1, year 2, year 3, up to year 5. You have the cash inflow for year 1, cash inflow for year 2, up to year 5. When we commence the project, we invested 500 million. Our expectation is to achieve a return year 1. Our expectation is that in year 1, we are going to get a return of 200 million. Year 2, our expectation is that we are going to get a return of 300 million. Let us assume in year 1. After year 1, our expectation is to get 200 million, but we only achieve 120 million. In year 2, our expectation is to get 300 million, but we only achieve 150 million. That implies that project expectations are not met. Now the question is, should the company continue with the project, or should the company abandon the project and sell the project? It is not compulsory that when you commence a project in year 0, then you must take the project to year 5 or to the final year. You can take advantage of financial flexibility. That is, you can abandon the project pathway and sell the project to another interested buyer. This is the concept of option to abandon. And option to abandon will be treated as a put option. This is the principle of option to abandon. And please note, option to abandon will be treated as a put option. That is the right to sell the project after some years. The right to sell. The right to sell. That is a put option. What are the steps involved? If you are dealing with question on option to abandon, what are the steps involved? If you are dealing with question on option to abandon, have you done this? Sorry, have we treated this topic?
We only started it.
I think, wait, oh, we did this last week, right? Have we treated this topic? I think yes.
Yes.
Sir, we only took the option to abandon.
We have treated it now. We have treated this. Okay, that's great. I thought we are just starting. Oh, that's fine. We now move to the second one. Oh, I didn't know we have treated this. Oh, that's fine. We move to option to delay. We move to the option to delay. Oh, that's fine. Yes, we treated this last week. Okay, fine. All right. Option to delay. Like I said, there are 4 areas of application. We have option to abandon, option to delay capital projects, option to expand a capital project, and option to switch. So we are moving to the second one. Option to delay a project. Option to delay a project. All right. What is option to delay? When a company undertakes a capital project, when a company has exclusive rights to a capital project or to a product for a specified period, when a company has exclusive rights to a capital project or to a product for a specified period, the company can decide to delay the commencement of the project to a later period. The company can decide to delay the commencement of the project to a later period. particularly if the project involves a great level of uncertainty. A company can decide to delay projects. A capital project that involves a great level of uncertainty. The option to delay provides opportunity for the company to monitor and respond to changes in the business environment, to changes in the risk level. The option to delay provides opportunity for the company to monitor the risk involved and respond to changes in the risk involved in the capital project before investing money in the project. I'll take that again. Option to delay a capital project, where a company is given a patent rights. A patent rights is the exclusive rights to a particular product or a particular project. That patent rights give the company the rights to be the sole producer of that product or that project within a specified period. Given that you have been given the exclusive rights, that means no other companies can invest in that project. You can decide to delay the project for some years before you commence actual production or actual implementation of the project. The option to delay provides opportunity for the managers, that is the company's manager, to be able to monitor the risk, the investment risk, and respond to changes in the risk before committing capital resource to the project. Under the conventional net present value method, under the conventional investment appraisal method, it is assumed that a project must commence now, year zero. If you are completing MPV, you are going to have year zero, year one, year two, up to the final year. The assumption with that computation is that the project must commence immediately. Conventional net present value ignores financial flexibility. The conventional net present value ignores financial flexibility. Option theory allows us to value financial flexibility. We can delay the projects for some years to take advantage of exclusive patent rights. Please note, option to delay will be treated as a call option. Please note, option to delay will be treated as a call option. Now, what are the steps involved? When dealing with option to delay, what are the steps involved? You have 3 steps involved. Let me try to detail it here. Steps involved. Steps involved. 1. Step 1. Calculate MPV without the option. Without the option to delay, step 2. Calculate value of call option. Calculate the value of call option. In this case, the 5 input variables are represented as follows. The 5 input variables are represented as follows. XO is equal to present value of future cash inflows. Capital letter E, initial investments outlay. Capital letter T, number of years the projects can be delayed. Your small letter R, the risk-free rates, and your volatility. Volatility, in bracket, the standard deviation. These are the 5 variables required. Then the final step. Step 3, calculates MPV with option to delay. With option to delay. This is equal to value of call option, value of call option plus MPV without option to delay. These are the 3 steps required. If you are faced with question on option to delay, these are the 3 steps required. Any question, please? Let us demonstrate this with the question below. Let us demonstrate this with the question below. If you check your study pack, Tayo Kayode, I think it's question number 7 or so. In your study pack, Tayo Kayode, let me try and check. Please, just 1 minute.
Page 115.
Let me try to reconfirm that page.
115.
Please, just 1 minute. Page 1, please.
115.
Page what? Oh, page 115.
115.
Question what?
8.
All right, thank you for that. Page 115. Please, just 1 minute. All right, sorry for that. Let's continue. So please refer to page 115. Let's go on with this question. Tayo Kayode is a highly successful beverage company listed on the Nigerian stock market. Its products are particularly attractive to the young generation. A collaboratory has developed an innovative synthetic alcoholic beverage, the Yonki. It is believed that the products, if manufactured commercially, will be popular among the youths. Kayode has been offered a license to produce the Yonki on the condition that it commences production within the next 12 months. The condition is that you can commence production within the next 12 months, within 1 year. In the last board meeting, the marketing director presented the following preliminary evaluation of the project. Look at the evaluation of the project. The net present value, please, that net present value is negative. It's in brackets. Please put it in brackets. The net present value is negative 250 million. The present value of future cash flows is 4,500. Kehinde, the marketing director, recommended that the project should be rejected. The finance director, Ben Okon, argued that the conventional net present value undervalues projects with high uncertainty, as the value of embedded re-option is often ignored. It suggested that the possibility of delaying the project for up to 12 months effectively give Tayo Kayode a call option on development. That is, we can delay the project for 12 months. That will give us effectively a call option on development. We are buying the right to develop the project within 12 months. That means no competitor can enter the project for that 12 months. If the market forecast improves over the next year, the company can benefit. To get the answer right, he concluded that option value must be incorporated. The current long-term government bond yield is 5%. The expected standard deviation of future cash flow is estimated to be 35%. Requirements. Comment requirement A. Let's deal with that first. Comment on the view of the marketing and finance director. Examiner said we should comment on the view of the marketing and the finance director. That is requirement A. I want to change this to, all right, let's go to this. Now, what are the views of this two directors. The marketing director is saying that the project has a negative net present value. Hence, we should reject the project. The marketing director is saying that this project has a negative net present value. Hence, we should reject the project. Now the question is the marketing director wrong? Is the marketing director wrong to recommend that we should reject the project? Of course, the marketing director is not wrong. Look at the comments. Both directors' views are correct to a point, but are failing to see the whole picture. The marketing director is correct in her interpretation of the calculated net present value. The net present value can normally be interpreted as showing the impact of a project on shareholders' wealth. A negative net present value is an indication that the project will reduce the wealth of the shareholders. A negative net present value is an indication or a confirmation that that project will reduce the wealth of the shareholders. Hence, the project should be rejected. Therefore, the marketing director is not wrong. The finance director is also correct to point out the weakness of conventional net present value. The finance director is equally right to point out the limitation of the conventional net present value. The conventional net present value undervalues financial flexibility. The conventional net present value ignores financial flexibility in capital projects. In just 1 minute. Let's continue with the class. We said the finance director is also right by pointing out the limitation of conventional net present value. High uncertainty is usually reflected in a high discount rate. Hence, it lowers the NPV. High uncertainty will give rise to higher risk. Higher risk will increase your discount rate. Increase in your discount rate will reduce your NPV. However, with high uncertainty, we have higher option values. We can value the financial flexibility. What is this financial flexibility? Is that It is not compulsory to start the project in year 0. We can delay this project for 12 months. By delaying the project, the company is able to watch, to monitor, and commence the project at a time that is more favorable. This is what we refer to as financial flexibility. However, the finance director is wrong to suggest that ignoring option is the only limitation of NPV. The net present value is a financial evaluation of projects. There are other factors. There are other factors that should be considered. What are these factors? Non-financial factors. When carry out project evaluation, we don't only consider the financial factors. The NPV only consider the financial factors. However, the other non-financial factors that can have impact on the project's success or failure. For example, we need to consider the implication of possible implications for Tayo Kayode image with alcoholic research beverage, alcoholic products targeting the younger generation. A company is trying to develop a new product, a new alcoholic beverage product, and the target market is younger generation. Some investors and customers may object to this link. That how will you develop a new product, a new alcoholic product, and your target market is the younger generation? That could have impact on the corporate image of the company. These factors must be considered also. So that will be your response to requirement A. That will be the response to requirement A. Okay, we say financial flexibility as it relates to the view of the finance director. The finance director has said that, look, we should not reject the project. The view of the finance director is that, look, we should not reject this project just because the project shows a negative net present value. Rather, we should try to value the financial flexibility. What is this financial flexibility? Is that it is not compulsory to commence the production of the project, to commence the project in year 0. The company has the option to delay the project for 12 months. You can postpone the project commencement to 12 months. By postponing this, by delaying the project for 12 months, that will give you the opportunity to monitor the level of uncertainty and to value the financial flexibility. The financial flexibility is the option provided to delay the project for some years or some months. I hope that is clear.
Yes, sir. Thank you, sir.
All right. Requirement 2. Requirement B, using the Black School option pricing model for European call option. Look at that requirement. Using the Black School's option pricing model for a European call option. Estimate the value of the option to commercially develop and market the Yankee. Provide a recommendation as to whether or not TK should manufacture the Yankee. Using the Black School model for European call option. Now the question is, what is European call option? What is European option? If you recall, we have the American option and we have the European option. Who can differentiate between these two?
One, the right can be exercised at any point for the European call option, while the American is at the end of the maturity period before the right can be exercised.
Who is speaking, please? Let me look at the who is speaking to this. All right, but you mix it up. You mix it up, please. American option. You can exercise your rights at any time from the commencement of the option up to the maturity of the option. American option, you can exercise your rights from the commencement of the option up to the maturity of the option. For European option, you can only exercise your rights at the maturity of the contract. If you look at this question, we have 12 months, within 12 months, to exercise our rights to produce the product. If you refer to this question, we have 12 months. Within 12 months, to exercise our rights and produce the Yankee. If you are dealing with European option, that means you are going to exercise your rights at the end of 12 months, at the maturity of the option contract. All right. Now this question is option to delay. What are the steps involved? If you are given question on option to delay, record the steps. Step 1. Step 1. Calculate net present value without option to delay. Examiner has done this for us. Look at it. Net present value of the project is negative 250 million. The net present value of the project is negative 250 million. Come here. NPV without option to delay is equal to negative 250 million. That's set to step 1. Step 2. Calculate value of call option using Black-Scholes, using Black-Scholes option pricing model. What is the formula for call option? Call option value is equal to XO multiplied by ND1, close your bracket, minus, open another bracket, capital letter E, exponential raised to power RT multiplied by ND2. Close your bracket. And we said XO, present value of future cash inflows. Examiner gave you this figure freely. At times, we ignore some question because we don't know. Look at it. Examiner gave you this freely. Present value of future cash flows, 4,400, 4,500. Look at it. It was there. SO, present value of future cash inflows. Pick the figure. This is 4,500. Your E, initial investment amount. This figure was not given to us directly, but we can derive it. To calculate present value, to calculate net present value is equal to present value of future cash flow minus initial investments. If you calculate NPV, how do you calculate your NPV? Your NPV is the difference between the present value of cash inflow minus the present value of initial outlay. Initial investments amount. We are told that the NPV is negative 250. Is equal to present value of cash flow, future cash flow, 4,500 minus initial investments amount. What is initial investment amount? We can collect light terms. Minus 250. This will come out here. Minus 4,500 is equal to minus initial investment amount. This will give me negative 4,750 is equal to negative initial investment. Initial investment amount. Negative, we cancel negative. That means my initial is 4,750. Your capital letter E is 4,750. You have gotten that. Your T, remember to value options using black schools. You require 5 input variables. Remember, if you are required to value options using the black schools model, you require 5 input variables.
Excuse me, sir.
Yes, sir.
Sir, please, I want
ahead.
to add, since it was 4-5 that crossed the equal to sign, and it was positive before. Okay, it's correct. I'm clear now. I was wondering why it was
Finance
4-7.
Minister, are you okay now?
Yes, I'm fine. I'm fine. Thank you, sir.
Time to maturity. What is the maturity of the option? 12 months. That is equal to 1 year. Your T is 1. Your R. What is the risk-free rate? Look at this, sir. The current long-term government bond yield 5%. The interest on government bond is the risk-free rate. and the standard deviation is 35%. Return to the question. The risk-free rates is 5%. That is 0.05. Volatility, that is the standard deviation, is equal to 35%. 0.35. You have gotten the 5 input variables. What next? Calculate your D1. D1 is equal to the formula in bracket XO over E, close your bracket, plus R 0.5 volatility square multiplied by T, everything divided by volatility square root of T. Pick your variables. Your D1 is equal to in XO 4,500, capital letter E 4,750, close my bracket, plus, open another bracket, my small letter R 0.05, plus 0.5 is constant, multiplied by volatility 0.35 square, close my bracket, multiply by what? 1 T divided by volatility 0.35 multiplied by the square root of T1. Please compute your D1. Let me stand up small. Please compute your D1. I'm waiting. Please compute your D1. I'm waiting around here. Your D1. There's final answer.
$0.1634.
What do you have?
0.1634.
0.163.
0.1634.
Yes, sir.
I think that should be correct. Yeah, I think it's correct. 0.1634. That is your D1. Once you are done, don't waste your time. Go to D2 straight. D2 is equal to D1 minus volatility square root of T. My D2 is equal to 0.1634 minus 0.35 multiplied by the root of 1. What is your D2? Yeah, I'm waiting.
Minus
-0.1866.
1866. Thank you. As soon as you are done, next, determine ND1 and ND2 using normal distribution table, subject to 0.5 plus or 0.5 minus. We move on. Pick your D1. Our D1 figure is 0.1634. Then establish a range. Look at the range. 0.16 between 0.16 and 0.17. This figure, 0.1634, lies in between 0.16 and 0.17. Now your ND1 is equal to, here you have a positive sign, plus 0.1634. Then you are going to start with 0.5 plus. Open a bracket. Now let's go to the log. Let us check the log. Where's the log safe? Maybe it's up. Look at the log. Where's the log? Abi is not here any. It must be here. I put the log here now. I just have the log on my system. Okay, look at the log here. We want to check this 1, 6. Look at it. 0.1. Trace it to 6. Under 6. 0.0636. That is 0.16. 0.0636. Then if you look at the second one, 0.17, 0.0675. You can return here. .16. That will give me 0.0636. You have checked 0.16. We are left with 34. Bring that down. Plus 0.34. Open another bracket. Now check 0.17. 0.127. That will give us 0.0675. minus the figure you have at the lower band minus 0.0636. Please compute your ND1. Please compute your ND1.
.5675.
ND1 is equal to
0.5675.
0.56. Is this correct?
I got 0.5649.
You have the same figure.
So I got 0.5649.
0.5649.
0.649. Yeah.
49.
Approximately 0.565.
No, is it for?
So what is the final answer?
0.5649.
5649. Okay. Oh. Final answer 0.5649. Please give me correct.
49. That's correct. 0.5649.
All right. Move to your D2. Your D2 figure is equal to negative 0.1866. Again, establish a range. This figure is between 0.18, 0.19. Now come to your ND2. The sign here is negative. You are going to start with 0.5 minus. Open a bracket. We are going to check 0.1 traced to 8 and 0.1 traced to 9. Let us go to the log again. Look at it. 0.1 traced to 8. 0.0714. 0.0714 and traced to 9, 0.0753, 14 and 53. Return up. .0714. That is 0.8 trace 0.1 trace to 8. You have checked points 0.18. We are left with 66 plus 0.66. Under bracket open. ICAN 0.1 trace to 9. That is 0.07. What is figure self? 0.07 what? I have to go back to it.
0.753.
Okay. 53, yeah. 53. This is 0 on your normal distribution log. 0.1 traced to 9 will give you 0.0753 minus the figure you have here, 0.0714. That will give you your ND2. What is ND2?
0.4260.
0.4260.
60. Somebody should please confirm.
Confirmed.
All right, we have gotten ND1 and ND2. We can value our call now. Value of call option. The formula is XO multiplied by ND1 minus E exponential RT multiplied by ND2. Therefore, our core value, our XO, 4,500. ND1, 0.5649 minus our capital letter E, 4750. Exponential, our small letter R, 0.05 multiplied by 1. Everything multiplied by 0.4. Let me put it here very well because of space. Everything multiplied by 0.4260. Please work this out. What is the value of call option? Please apply your calculator. What is the value of the call option?
841.89.
Got minus.
Yes, sir.
You can't get minus.
So I got 617.237.
Correct. 617 point something. You can never get minus. Option value can never be minus. 617 point what, please?
237.
Thank you. 617.237. We have solved this question in the physical class. And the answer we got was 617.24. That means they approximated. You can approximate. That will give us 617.24. That is the value of your call. And please note, option value, whether put option value or call option value, you can never get negative. That normal distribution log has been programmed. That log, once you are using that log correctly, your figure cannot be negative. The highest that could happen is 0. It can't go to negative. So if you compute and you get negative, just go and start again. All right, we have resolved step 2. The final step, you have step 3. Step 3, calculate MPV with option to delay. This is equal to value of call option as calculated in step 2. This gave us 617.24 plus MPV without option to delay. That gave us negative 250. Negative. Then please sum these two. That will give you value of option to delay. This is the value of option, value of option to delay. Value of option to delay. What do you have, please?
$67.24.
3 what?
67.24.
67. How?
367.
Oh, 367.24. Okay. Thank you. You are done with step 2. You are done with requirement B. Sorry. Oh. You are done with requirement B. You have used the Black School model to value the projects.
Excuse me, sir.
Look at that requirement. And why not? Please hold on. If you want to have a question, please just indicate. Look at the question. Using the Black School option pricing model, estimate the value of the option to commercially develop, and market the Yankee. You have estimated the value of the option to commercially develop and market the Yankee. That gave us 367.24 million. And that's a positive sign. Provide a recommendation as to whether or not TK should manufacture the Yankee. Because the value of the option The value of the option to commercially develop and market the product is positive. Positive 367.24 million. That means the project is financially viable. All right. Tony, your comments. Anthony, your comments?
No, okay, I've seen what I was looking for. I'm okay with it.
Okay, you
It's
have
fine.
seen it.
Yes, sir. Thank
All
you very
right.
much, sir.
So our recommendation. Our recommendation. The value of option to delay the project for 12 months is 367.24 million. This is financially profitable. Profitable. Hence, the company should commercially develop and market the products after 12 months. That's set to requirements B. Yes, requirement C. Damilola Olawi, your
Yes.
comments, your question?
So I have a question. So for this comment B, is it possible for them to actually use American call option? No, we are using, yeah, we use European, which says we have to delay until maturity period.
Okay, your question is it possible to use American option? That
Yes,
your
sir.
question, please.
Yes, sir. Yes, sir.
All right, you can mute. The question you ask is the question for requirement C. The question you ask is the question examiner asks us to treat in requirement C. But let me explain it. Black school model cannot be used to value American option. If the company should commence the project before 12 months, that will take us to American option. American option, right? You have the right to exercise, you have the option to exercise your rights within any period from the commencement of the option contract up to the maturity of the contract. That means if the company commences production before 12 months, at any period within 12 months, that will take us to American option contracts. And Black School model cannot be used to value American option contracts. That takes me to requirement C. Comments on modeling the possibility of delay as a European call option. Look at the comments. The Black School model was developed for European options. Full stop. As production could commence at any time during the 1 year, during the 1 year period, the option is an American option rather than a European option. Because the terms of the contract says you should commence production within 12 months. That terms of the contract is an American option contract rather than European option. It can be argued that where there is no dividend payable and where time value still exists, it is worthwhile holding an American option to expiration. What we are saying is, if we decide to wait until the end of 12 months, then our valuation is okay. If CK decide to exercise his rights at the end of 12 months, thus the valuation as a European option is valid. But if the company decides to exercise its rights within 12 months, then that valuation above will not be valid, because that will take us to American option. It is likely that the investment will commence after 12 months. In that case, our forecast profits, that is our forecast net present value, will now change to positive. That is the positive figure we derive, 367 million, provided we delay the project for 12 months. That will be fine. But if the contract is exercised, if the option is exercised before 12 months, that valuation above will be wrong. That will be your expected response to requirement C, and by extension to the question from Damilola. Any other question, please? All right. We have taken question on option to abandon. We have taken question on option to delay. We have just like 40 minutes. Let us look at option to expand. We have about 40 minutes. Let us look at option to expand. What is option to expand? How do we treat option to expand a capital project? All right, let's go to this. All right, look at the next one. Option to expand. Option to expand exists when firms invest in projects or products which allow them to make further investment in the future or to enter into new markets. Option to expand exists when a firm invests in capital projects or when a firm invests in a product which allows the firm to make additional investment in the future, or the project allows the company to enter into new products or new markets. The initial projects may not be financially viable. The initial projects may not be financially viable. But the project provides opportunity for expansion. But the projects provide opportunity for expansion when the option to expand is taken into consideration. The net present value of the project may become positive and the project becomes worthwhile. I will take that again. Option to expand. Option to expand exists when firms invest in projects that allow them to make further investments at future periods, or the project allows them to expand into other markets. The initial projects may not be financially viable, but these projects provide opportunity for expansion when the option to expand is taken into consideration. The net present value of the projects may become positive and the project becomes financially viable. The initial projects may be considered as the option or as the premium required to acquire option to expand. Expansion will normally require additional investment. The additional investment is the exercise price. Option to make additional investment in the capital project. Please note, option to expand will be treated as a call option. Please note, option to expand will be treated as a call option. Steps involved. If you are dealing with question on option to expand, step involved. If you are dealing with question on option to expand, this question is duplicated. So right there now. What are the steps? Step one, look at it. Steps involved. Step one. Calculate the option to expand step two. Calculate value of call option. Full stop. In this case, the five input variables are represented as follows. SO, SO is equal to present value of future cash flow after expansion. Capital letter E. Additional cost of expansion. Additional investment or cost of expansion. Your T. Here, the projects the project will be expanded. How? The risk-free rates, then volatility. In brackets, standard deviation. Those are the 5 variables required. Then the final step. Step 3. Calculate MPV with option to expand. This is equal to value of call option plus MPV without option to expand. Those are the 3 steps involved. Those are the 3 steps involved when dealing with question on option to expand. Play just 1 minute. If it is possible to take question on this, you can try it. While waiting for question on this, your study pack, the new study pack was released today. Interestingly, a lot of surprises. But for me as a person, I wasn't surprised by what ICAN gave us. I wasn't taken by surprise. The first surprise in that syllabus is that all the topics that were taken to FM at the skills level was also retained. All those topics has been removed from the syllabus, SFM syllabus, and they were taken to skills level under financial management. But when I can release the study pack, all those topics in FM were still repeated in SFM. For me, I wasn't surprised. I can read between the lines. The thinking of ICAN is for you to be professional, you have passed through skills and you have learned financial management. It is assumed that you have gotten the knowledge of financial management that qualifies you to write strategic financial management. So I wasn't surprised. So all those topics in FM, it's assumed that you have learned it. What are these topics? Some of them I can remember. One of them is source of finance, finance success. Finance success was taken from SFM to FM. And that's why we are not treating finance success again. Source of finance. It is assumed that you understand the different sources of finance. And ICAN can decide to text it. All right. Look at your study pack. Let me bring this question here. I think page 116 or page 117. The question on FFK and Co. Let me even check. That was study pack. I don't even have it like that. So
Page 113, illustration 5.
page 113.
Yes, sir.
Oh, thank you. Illustration what, please?
5.
Oh, okay. Oh, okay. Page 113. Page 113. Question 5. But let me try if you can deal with this question. We have precisely 20 minutes. All right. Please, let's refer to the page. FFK and Co. manufactures heavy agricultural equipment and machinery, which can be used in difficult farming conditions. FFK Chief Executive has been investigating a significant opportunity in the country of Naswa, where FFK and Co. has not previously sold any product. The government of Naswa have been undertaking a major land reclamation program, and FFK equipment is particularly suitable for use on the reclaimed land. Because of the cost and other problems involved in transporting its products, FFK and Co. Chief Executive Officer proposes that the company should establish a plant for manufacturing machinery in Naswa. He knows that the Naswan government is keen to encourage production of sustainable businesses. Government of Naswa is keen to encourage development of sustainable businesses within the country. Initial calculation suggests that investments in Naswa will have a positive net present value. Look at it. If you make investments in Naswa country, Naswa, we are going to get a negative net present value of 1.01 million. That means the initial investment is not financially profitable. However, FFK chief executive believes that there may be opportunities for greater cash flow in the future if the Naswan government expand its land reclamation program. Look at this. There's opportunity to expand. If the government expands its land reclamation program, the government at present is struggling to fund expansion of the program out of its own resources and is looking for other funding. If the Naswan government obtains this funding, chief executive has forecast that the increased demand for FFK and co-products would justify 15 million additional expenditure at the site of the factory in 3 years' time. Look at it. We can make additional investment at the site in 3 years' time. The expected net present value for this expansion is currently estimated at 0. That means if you invest additional 15 million in year 3, you are going to get NPV of the expansion is 0. It can be assumed that all costs and revenue, including inflation, relevant cost of capital is 12. The risk-free rate is 4. The chief executive has estimated the likely volatility of cash flow. Not cash flow, please. Likely volatility of cash flow. Cash flow at a standard deviation of 30%. One of FFK and Co. non-executive director have read about possible changes in interest rates and wonder how this might affect the investment appraisal. Requirements A. Assess showing relevant calculations whether FFK should proceed with the significant opportunity, discuss the assumptions made, and other factors which will affect your decision of whether to establish a plant in Naswa. The black school pricing model may be used where appropriate. This question was taken for ACCA, but although the question is very long, do not be disturbed by the length or the noise of the question. Your focus should be on the what? On the principle. This question is about option to expand. Now, what are the steps involved if you are dealing with option to expand? That is the question we should ask ourselves. What are the steps involved if I'm to deal with option to expand a capital project? That should be our concern. We are less bothered about the length of the question. Our concern is, I want to evaluate this project. I want to evaluate the significant opportunity of expansion. How do I go about this? Anywhere we get to by 11 p.m., I want to believe that by the time we solve this question, solving or completing it will not be a problem. Once we are able to start this question, we have the step. I'm just trying to create a space. Let me do one more. All right, back to calculation. Look at it and pick my pen. I'm dealing with option to expand. Option to expand. Step 1. Calculate MPV without option to expand. Examiner has done that for you. Look at it. Initial calculations suggest that the proposed investment in Naswa, we have a negative MPV, 1.01 million. Pick that. without option to expand, NPV without option to expand is negative 1.01 million. Step 2. Calculate value of call option. State the formula. XO multiplied by N minus E exponential RT multiplied by ND2. Present value of future cash flow after expansion. Our E, additional investment cost. Look at it. Look at this. The government at present is struggling to fund the expansion of the program out of its own resources and is looking for other funding. If the NASWAN government obtain this funding, Chief Executive has forecast that the increased demand for FFK and co-products will justify 15 million additional expenditure at the site of the factory in 3 years' time. That means additional investment cost 15 million. The expected NPV of this expansion is 0. Okay. Look at it. My E is 15 million. That is additional investment. Present value after expansion. Look at this. I want to calculate X, XO. Look at the working. Is equal to additional investment cost. Now I want to take this out. Present value of cash flow after expansion present value of cash flow after expansion minus additional investment cost of expansion. Look at it. Our expected NPV after expansion is equal to present value of cash flow after expansion minus additional cost of expansion. Examiner says NPV after expansion, 0. Present value of cash flow after expansion, I don't know yet. Minus cost of expansion, 15 million. What is the present value of cash right now? I'm trying to manage time because someone might want to get it on now. Somebody might say, I'm not in class, so how can I now get X now? The present value of cash flow after expansion minus 15. This is 0. If I cross minus 15 will come here. That becomes plus 15. That means present value of cash flow after expansion is also 15 million. Our XO is also 15 million because the expected NPV will be 0 after expansion. If I invest 15 million after expansion, my expected NPV is 0. That means the present value of future cash flow after expansion must give me 15 million. 15 minus 15 will give us 0. I've resolved that. Your T, year of expansion, year 3, 3 years. Look at it. Look at it. Would justify 15 million additional investment at the site of the factory in 3 years' time. Expansion will happen in 3 years. Your risk-free rate, 4%. Standard deviation, 30%. Our R, 4%, 0.04. Our standard deviation, 30%, 0.3. You have gotten your variable D1 in bracket equal E close brackets plus arrow is to power T multiplied by T divided by volatility square root of T. D 15 plus open another bracket 0.04 plus 0.5 is constant multiplied by volatility 0.3 raised to power 2. Close my bracket. My T multiplied by 3. Everything divided by volatility 0.3 multiplied by the root of 3. Get your D1. When you are done getting your D1, because I have to stop here, I'm stopping here because of time. If for some of us that have been following this and we understand this, you can complete the question now. Because you are going to get your D1. After your D1, what do? You are going to get your D1 figure, then your D2. D1 minus bracket root of T. When you are done, what do we do? I'm creating space for this. Determine ND1 and ND2 using normal distribution table, subject to 0.5 plus or 0.5 minus. Once you get your ND1 and ND2, what next? What next? Value of call option. That will finish your step 2. You get your answer. Your step 3. MPV with option to expand. This is equal to value of call option plus MPV without option to expand. These 3 steps, we address part A. I'm going to stop here because the agreement is to run till 11 p.m. My expectation is that we are going to try to complete these requirements. All right, any question? Any question, any comments? All right, I will be checking out of the classroom. May God give us a better understanding.
Amen.
And God enrich us in knowledge and wealth.
Amen.
Good night.
Thank you, sir.
Good night, Papi.